We're talking about 14.7. In addition to the B and C level problems, I want to give you the answers to the even problems 14 and 16. So 14 is a sentence. It says, by definition, the identity mapping I maps every point P to itself. Okay, remember the idea of an identity. In multiplication, the identity is the number 1. You can multiply any number A by 1 and get itself. So that's the idea. That's why it's the identity, right? It preserves its identity. So the identity mapping, this is just a definition, maps every point P to itself. So in the identity mapping, P is equal to P prime. Okay, for 16, the inverse of H sub 0. H sub 0 is a half turn. So the inverse of a half turn is going to be a half turn. You know, let's draw a little picture here. You take a point and you go 180 degrees. All right, then how do you get back? You go 180 the other direction, minus 180. All right, or you could keep going another 180, another half in the positive direction. You're going to end up where you started. Okay, so the inverse of a half turn is a half turn. All right, 21. Now we're going to start talking about the B-level problems. Okay, so for 21, it says in each exercise a rule is given for mapping S. So mapping S takes xy to x plus 5, y plus 2. Alrighty, so they want us to take the rule, write a rule for the inverse. Okay, so you can see if you take x, if you add 5 to something, the way you're going to undo that is take 5 away. If you add 2 to something, the way you're going to undo that is take 2 away. So, you know, to really show that it's an inverse, I have to compose S with S inverse and S inverse with S and show that when I start with is what I end with. Okay, so we can look at this. S inverse takes xy to x minus 5, y minus 2. And then I'm going to take this point now and apply S to it. So what S does is it takes my x and it adds 5. So this time my x is x minus 5, and then I got to add 5 to that. Okay, S takes y and adds 2 to it. So this time my y is y minus 2, and I got to add 2 to that. So x minus 5 plus 5 is x, y minus 2 plus 2 is y. So you can see if I start at xy, I end at xy. So those two are indeed inverses of each other. Inverses, you know, it takes a point back to itself. If you compose a function with its inverse or a mapping with its inverse, it takes a function, or it takes a point back to itself. All right. In the same way here, I have to. I've got to check S inverse composed with S. Here I checked S composed with S inverse. I want to make sure that both directions work. Okay, whether I do S inverse first or whether I do S first. When I compose it with the inverse, it needs to take a point xy back to itself. So xy under S, it adds 5 to x and 2 to y. Okay, this becomes my new starting point. S inverse takes 5 away from S, from x, excuse me, so I have x plus 5 minus 5. Here I have y plus 2 minus 2, and so you can see it brings it back to xy. Okay, so that's 21. All right, the next problem is 23. 23, we need to find the inverse of 3x and minus a half y. All right, so the inverse, you can tell if you're multiplying x by 3, the way to get rid of that is divide it by 3. So 1/3 x. All right, and then if I multiply y by minus a half, if I multiply it by 2, that's going to bring y back to itself, okay? And so, again, I need to check just to make sure that when I compose my S inverse with S, that I take xy to xy. All right, so that's good. And you can see the work there. xy under x inverse, x gets cut by a third, excuse me, and y gets multiplied by -2, and then this becomes my new starting point, and then I apply S. When I apply S, I multiply 3 times whatever x is. In this case, x is 1/3. You know, this is my x now, right? So I have to multiply 3 times that value there. 3 times a third x gets me back to x, and then I have to multiply for y, whatever y is, and in this case, my y, what's in my y position is -2y. Multiply that by a half. Okay, negative a half times negative 2 gets me back to y. So you can see that that happens there. And then I just have to go the other direction too on this one. Excuse me. I have to show that S inverse composed with S takes xy to xy. All right. Before I had showed that S composed with S inverse took xy to xy. Now I got to show the other way. All right. You know, you'll be doing this in Algebra 2 and in Pre-Calc, so what the heck, I'll explain it to you now. Okay, so here, S takes xy to 3x minus a half y, and then now I'm going to take S inverse. S inverse, you can see, it takes your point and it multiplies it by a third. It takes your x value, which is 3x, and multiplies it by a third. And it takes your y value, which is minus a half y, and multiplies it by negative 2. So you can see a third times 3x, that's x. Negative 2 times minus a half x, that's y. So you can see that I start out with xy, I end up with xy. So the composition of functions take xy to itself. All right, so that is done.